Today we are going to present another project, which is generative design using SolidWorks. My group members are Aladin Ahmed, Sanjidul Ahmed, and me, myself, Mohammad Munif Hassan. So, what is generative design? Generative design is an artificial intelligence and algorithm-driven design approach where the designer or the engineer defines goals, requirements, and constraints such as material manufacturing methods, load conditions, costs, weight. It is usually used following sectors in aerospace, automotive engineering, architecture, construction sector, manufacturing, robotics, mechanical and mechatronics engineering, research and development sector. So our primary design is a 3D printed bridge components are often used for mechanically fragile, and this is a limitation is particularly evident with ABS. Consequently, achieving a design that reduces weight while maintaining sufficient strength to withstand the required load poses a significant challenge. To address this issue, generative design techniques are employed to identify optimized geometries that ensure the necessity of the structural performance. For this project, we aimed to fabricate a 3D printing bridge using ABS, selected with a widespread using a suitable mechanical properties. Our objective was to determine an optimal bridge configuration that minimizes material consumption and overall weight while maintaining an adequate structural strength. To accomplish this, we utilize the generative design tools in SolidWorks, which enables the exploration of material efficient design and alternatives that meet the required performance criteria. For the material selection, after defining the dimensions in the materials, we selected for the prototype to be printed SolidWorks has its built-in materials lab and database. Our targeted material for this project was ABS, which is a common impact resistance engineering. Thermoplastic is often used for 3D printing. The designated mechanical properties were reviewed in a default library in SolidWorks. Next, I would like to invite Sanjidul Ahmed to discuss about the simulation.
Can you hear me, Munif Hassan?
Yes, I can hear you.
Okay, I'm Shantidul Ahmed. I'll carry the rest of the part from here. After that, we'll study the simulation. For this, we'll go to the tab of simulation in SolidWorks software. There we will find the topology study. We'll select the topology study and rename it at topology study 1 for our study. Next slide. And after that we'll set the fixture. We have to fix the geometry in a particular region so that our so that it will be fixed in that section, and it will not deflect or it not deviate from the section. For this option, we'll fix the geometry at phase 1 and phase 2. From slide we can see that from the bottom right side and bottom left side is fixed with the green arrow perfectly. So after that we'll set the force on the surface. Next slide. After that we'll set the force on our prototype prototype bridge. For this, we'll select a downward force on the surface where all the vehicles or man will pass us on. We'll select a 10,000 Newton of face on the downward force on the phase one, and this will be done in the force or torque option. After that, we have initiated topology study. We have fixed the geometry in particular region. We have set the force on it, and then we have to fix our goals and constant of this study. Our goal in this study is to uh, minimize the mass of the part, and sorry for the interruption. Our goal was to minimize the mass of the part, and we have to select our constraint, like displacement constraint. For minimizing the mass, we have targeted to reduce the mass by 25%. Our current mass of the part is calculated as approximately 4.7 kg, and our our target of final mass of the part should be around 3.5 kg. And for the displacement constant, it is specified, the factor is specified as 2.1.2. For the displacement, to introduce the displacement constant, it is a boundary condition in engineering that specifies a known and fixed displacement in a specific direction or set of direction for a model or object. From here, my another teammate Aladdin Ahmed will continue. Thank you.
So in here, actually, what we did actually, we setting the manufacturing control. What is that actually? This is some some levers that manufacturer have when designing something. Like they want this part to be stay there, and we want our top surface to stay there because cars will move from there. Supposedly, car will move from there. That's why. And in the next slide, for the simulation, we have to apply the mesh, and we choose the mesh not to be coarse, and we also choose the mesh not to be fine too, because if we choose the fine, then it will take tons of time. That's why. In the next slide. So after simulation, as we can see, some material were removed, and we left with this design. And we also calculate the mass is 3.77616 kg, but the mass was supposed to be 3.5 something. But the mass was around reduced to around 20%, which is less than 5% as our anticipation. But this mass are required for the design to work properly. And we also see which mass must be which mass we must have to keep and which are okay to remove. The YOLO mass means actually those mass we have to keep, and from the down those mass we can remove, and the design already removed some of them. Yep. The next slide. And here we simulated the stress, and as we can see, the parts that parts face the most stress are at the top middle. And from the previous design, we can also say that those were the places the materials were in. So what they did actually, they calculated the stress, and as per the stress in different portion of the design, they put mass, and where there aren't enough stress, they just removed it. That's how the design actually worked. That's how the simulation actually worked. Yep. The next slide. Thank you all. Thank you for the present. Thank you for staying with us.